Welcome to today's video lecture where we are going to cover how to convert from mass of one substance to the mass of another in a chemical reaction. In order to do this, we are going to first run through a few steps to do so, and then we're going to concurrently work through a sample problem as we do it. So why do we do this? Let's say that we need to produce a certain amount of product that we just need to use in a chemical reaction. We are able to determine what mass of reactants we need to start with in order to produce that amount of product. So again, this is like our tricycle problem, where if we need to make 3 million tricycles, how many wheels do we need to purchase? All right, so here are our steps. Our first step is going to be to write the balanced chemical equation. And then down below, we are going to read our first sample problem. The Haber process allows for the industrial production of ammonia. Without the Haber process, we would not have things like Windex or ammonia-based fertilizers. The Haber process works through a catalyst that takes our atmospheric nitrogen and combines it with hydrogen gas to produce ammonia. If we add 50 grams of hydrogen gas to atmospheric nitrogen, how many grams of ammonia do we make? All right, here's our chemical equation, step one. We start with hydrogen gas, so H2. Plus N2. Have no fear of, those are both diatomic elements. Have no. Then we're going to produce ammonia, not ammonium, but ammonia, which is NH3. All right. Now that's a tricky one because we've got an odd number of H's and an even number on the left. So first thing we'll do is make that an even number. 3 and 2 is 6. Now we have 2 nitrogens. Now we're good. All right, that's balanced. Check. Step 2. Now, once we've got the balanced chemical equation, in order to convert from one substance to another, we must first convert to moles. Once we convert to moles, then we're able to cross the mole bridge. The mole bridge allows us to convert from one element to another, or one compound to another in a chemical equation. And then once we've traversed our mole bridge, then we can finally get to our destination, which is grams of ammonia. So our first step is going to be to convert from mass of A to moles of A. Now, these numbers come from the periodic table because this is our molar mass. And by definition, the molar mass is the mass of 1 mole of a specific element or compound. All right, so step number 2. We're going to start way over here on the left because I'm afraid that we might run out of space if we don't. So we start with 50 grams of H2 gas. Unit belongs on the diagonal is grams of H2. Always match up the units. So whatever unit is written on the left must be written diagonally across on the bottom. Then the unit that we're going to convert to, which is moles of H2, belongs in the top right-hand corner. All right, we're going to look at our periodic table. I see that hydrogen has a molar mass of 1.01. So 1.01 times 2 gives us 2.02 grams per mole. Now, since it's always grams per 1 mole, I'm going to fill the 1 in first on top. That means that we have 2.02 grams on the bottom. Now, in order to calculate that, we'll swap over to our trusty dusty calculator, and we will divide 50 by 2.02. We get 24.75 equals 24.75. Now, when I cancel my units, we're left with moles of H2. All right, now that we've converted from mass of A to moles of A, now that we have moles, we can go anywhere that we want. So this is our mole bridge. We can convert to moles of B. All right. Now, in order to convert from moles of A to moles of B, again, this is our mole bridge. This is a fantastical, bridge. It's a fantastical bridge because we are able to convert from one element or compound to another. Again, these numbers always come from our coefficients. All right, step 3. We have 24.75 moles of H2. Unit on the diagonal is moles of H2. Unit up top is the one that we're looking for, which is moles of ammonia. Now, our coefficients, we have 3 moles of H2 and 2 moles of ammonia. So we drag those over from the balanced chemical equation. Now, we're going to pull out our calculator, and we have our 24.75, multiply that by 2, divide that by 3, and then our next answer is 16.5. So we'll write 16.5. My units cancel. We're left with moles of NH3. All right. Now that we have crossed the mole bridge, now we have moles of NH3. Now we know exactly how many NH3 molecules we have. And next, all we have to do is convert from moles to mass. So we're going to convert from moles of B to mass of B. Now this equation or this process will look oddly familiar because again we're going to get our molar mass from our periodic table, and again we always use 1 mole. All right, so over here, step 4, we have 16.5 moles of NH3. Again, the unit on the diagonal is always moles, is always the same, so it's moles of NH3. And then on top we have what we're looking for, which is grams of NH3. Again, we're going to take a look at the periodic table. I see that nitrogen has a molar mass of 14.01. We have 1 of them. Next, hydrogen has a molar mass of 1.01, and we have 3 of those. 14.01 plus 3.03 equals 0.5, 17.03. Goodness, math today. 17.03 grams per mole. All right. Oops, I'm sorry, 17.04. Goodness. 17.04 grams per mole. All right. 17.04 will go up top per 1 mole. Why? Because it's always 1 mole. But wait, why is it that we have mass on the bottom here and mass on the top here? Well, over here we started with grams and are converting to moles. Over here we started with moles and are converting to grams. So these ratios we must use the inverse of in order to get the correct answer. Next, we're going to plug that into our calculator, multiply our answer by 17.04 times 17.04, and we get a grand total of 281.19 grams of NH3. There we go. Hopefully this is helpful, and enjoy.